Introduce our next speaker, Barry Fishler from Lawrence Livermore National Laboratory. He's going to be speaking on the maintenance of large-scale control systems over multiple decades and using the National Ignition Facility as an example.
Thank you, Chris. So since NIF was commissioned as an operational facility back in 2009, we've seen a high volume of change within its control system, ICCS. Much of this change has been the addition of new features and capabilities that have been requested from experimentalists, laser physicists, as well as operational staff. And then we've also seen a considerable amount of change in regards to maintenance. So I'll be talking about changes we've made to our development processes and design in order to manage this high volume of change, but also how do we keep ICCS sustainable over its 30-year lifespan. So this chart shows various influences on the ICCS design and our development processes. The one I'd like to talk about is regarding staffing. We have seen a high volume of retirements recently, and some of these developers were the original designers of the control system. And with the retirement, there's a considerable amount of knowledge that we lose from our organization. In addition, we're very close to Silicon Valley out in the East Bay, and the culture and the money of Silicon Valley can be a tremendous draw for some of the newer developers. The Silicon Valley culture as well, we see that the average amount of time that a developer stays within a project is around 2 to 3 years before they're looking for a new technology or a new project to work on. So there is high turnover, and therefore we've had to make changes to our processes to help accommodate that. So Henderson and Clark authored a paper from MIT regarding 4 different types of innovation that can be defined along 2 dimensions. The first dimension being component knowledge. So that's the amount of change that is altering a component's behavior, its internal behavior. And then the second dimension is regarding architectural changes, so changes to the linkages between those components. Now, what I've plotted on this graph are various upgrades to the control system in NIF. And this is over about a 5-year time span, and this includes changes that we've already completed, as well as changes that are upcoming in the next couple of years. And the point behind this is to show that we are seeing a high number of changes both on the component and the architectural axes. And changes along those 2 axes require different strategies in order to manage them effectively. So here we see the V model for systems engineering. Down one side we see the decomposition and definition phases of a project. And then along the other side of the V, it's the integration and test phase. And these links between the 2 sides of the V represent the verification and validation plans that are used to ensure that the requirements that come out of the decomposition and definition phases are addressed effectively in the integration and test phase of the project. And for NIF, we have plans both from a production and an offline test bed environment. However, NIF did an exceptional job in making sure that we had those plans in place prior to controls coding, before the coding began. However, when we shifted into a maintenance phase, that documentation and these plans, they gradually drifted out of date. And we were reliant on subject matter experts to maintain that knowledge, but with the retirements, it left us in a pretty bad spot. In addition, a lot of those plans and procedures were very manually intensive, and as the features and capabilities grew and changed, the amount of manual effort required to execute those plans just couldn't be done. And a lot of the gaps in these plans became apparent during the Ada to Java porting activities that Gordon Brunton spoke about on Monday. So we had to make some changes as part of the Java porting effort to address them. So to address component level changes, as part of the Java porting activity, we mandated that automated testing be incorporated into that process. We used a test-driven development methodology where the developers were required to develop those test cases prior to starting the Java coding, and then run those test cases against the Ada processes and have the test cases reviewed by various stakeholders to ensure that the test cases were complete. Once the Java coding was completed, then we re-executed those test cases and compared the results between Ada and Java. And we actually had to pause the Java porting activity to make this happen. We developed a testing framework that we incorporated into a continuous integration environment so that we would have constant and immediate feedback on the quality of the code changes that were being applied to the build. And there were some long-term benefits that are coming out of the automated tests. I spoke about the immediate and frequent testing that was going on as code changes were being applied. With our build process, any issues were immediately apparent. But then also those test cases provided the documentation for the behavior of those components. So for new staff that were coming in, they had a reference for how those systems were to run. So that accelerated the onboarding of those developers into the team. Then more from an architectural standpoint, again, it was automated testing. So we came up with a automated shot test engine that would allow users to run an end-to-end NIF shot in an emulated environment. It also allowed the injection of off-normals, facility reconfiguration events, and experiment updates that normally happen in a production-like environment. Now, with all of this automated testing, we still have a need for manual testing. However, we felt the effort spent in testing was better spent in doing deep dives into the subsystems as part of the broader system, but also to do more exploratory testing where it's unplanned to find more defects. And then the Java porting activity has allowed us to simplify our build environment with the Java being compiled into bytecode, which the JVM engine then interprets. We're able to consolidate the number of operating systems that we had to support as part of our build process. Much of the Java processes that we're developing at the supervisory layer we're running on virtual machines, running primarily Linux, but we have a few handful of Windows systems still. And then at the FEP layer, we have VME-based single-board computers that are running a customized Gen 2 Linux distribution. So Linux is the focus for operating systems going ahead. Now, this chart shows our VME processor conversion to these new Gen 2 based FEPs. This red line indicates the procurement rate for those single-board computers. And as you can see, we've been buying those in bulk, and the intent behind that was to minimize minor manufacturing changes that happen as these boards are being built. And the graph below indicates the actual deployment rate of these computers into the production environment. And as you can see, it's been kind of flatline. And then at this point, there's a dramatic acceleration of the deployment of those single board computers. And that is due to the coding complete of 95% of the devices that we need for the majority of these VME-based processors. So I'm pleased to report that we have a preamplifier module that's part of NIF in a production lab that's currently undergoing commissioning. And later this month, we plan on deploying a first article into the NIF facility for commissioning during a shot. And at that point, this dramatic deployment rate for those single board computers will be realized. So this represents the preamplifier modules as well as the bulk of the alignment controls FEPs that we'll have the first article going out in December of this year. I also wanted to share one success story that we had recently. The facility timing transmitter takes the master clock signal from the GPS time server and converts it into an optical timing trigger that's then distributed across NIF. And this was a proprietary system and one of the original, if not the original, subsystem within NIF. It was created back in the 90s. Since then, the manufacturer of that system has been bought and sold multiple times. The new company didn't want to talk to us without an upfront investment from us. In addition, we had been provided the source code from the original manufacturer, and that source code was kept in escrow. However, we have had updates to the firmware within the FTT, so we weren't sure that, we didn't have a lot of confidence in the source code that we had. So, and again, we lost the subject matter expert that was responsible for the system. So we reached out to Greenfield Technologies, who we contracted out to build a replacement system that was supposed to be a drop-in replacement for the existing FTT. And as part of this, we shipped them ICCS in a box. So it was the complete ICCS build, complete with a navigator running on a single Linux host. And that, in addition to the Linux build, the ICCS build, we provided a suite of automated tests, which really defined the factory acceptance test requirements for the FTT. So the GFT was able to run these automated tests to provide assurance that what they were building was correct. So if you look closely at this photo, you'll see that these engineers are in fact smiling. That's because we did successfully deploy the FTTs out into the production environment, and there they are there kind of running in the background in a test environment. So in summary, it's important to modernize your technologies going forward, and the reliance on subject matter experts to provide the knowledge that's necessary to maintain a system is just a failed strategy. There needs to be a different solution to ensure that knowledge stays local. And then we've been using automated testing to document requirements and the behavior of the systems. And that's not only to provide quality and frequent testing, but also to document the system for new employees. And then also the simplification of runtime and compile time environments. So having multiple operating systems, multiple languages, it's important to try to consolidate to avoid having additional end-of-life issues as the project moves forward. Thank you.
Questions?
Wait for the microphone.
What was the what? Sorry.
performance?
The impact on performance?
Did you have any impact on performance moving from Ada to Java?
I mean, one of the issues we had with Java early on was garbage collection. The JVM will periodically wake up and free up any memory that was previously allocated by the source code. And early experiences indicated that was, we didn't have very much control on that, and it was causing significant delays and performance issues in the operation of the system. Since then, we've actually built frameworks to force garbage collections at opportune times within the shot cycle so that we don't have these garbage collections waking up like 5 seconds prior to the shot, stalling critical operations and interfering with the shot cycle. So from an overall performance standpoint, I think Java has been, I would say, comparable. Probably within specifications is the best way to put it. I think the garbage collection was definitely the primary issue, but we've gotten past that. But Java has been performant enough to meet our needs.
Last question.
Hello, thanks for the presentation. You showed us the V model, which is kind of strict waterfall framework where everything has to be written and specified upfront. But then you also perform TDD, so test-driven development, where even before having a solution, you write the test and then you write the code that should. So you know what you want to achieve, you don't know how, and then you write the code as to pass that test. So wasn't that kind of controversial with the V model where everything has to be upfront, specified?
I may have misspoke. So I don't want to leave you with the impression that those plans were developed before any of the coding and development and the manufacturing occurred. It was kind of done as part of that process. It wasn't necessarily done up front, but by the time we got to the integration and test phase or activity, that's when those plans or procedures had to be mature. Does that answer your question?
I think so.
Okay. Sure.
Okay, I'd like to thank the speaker one more time.